Hey everybody, it's Mr. Carr again. Today we're going to be talking about 2-6 day 1. So what we've covered in the past already is solving polynomial and rational equations. Now we're going to be talking about polynomial inequalities, and the next one we'll talk about is rational inequalities. So instead of solving for zeros, we're going to solve for a range of values with our inequalities. So here's what this one looks like. The first thing I'm going to do, I'm going to go through this and solve it all algebraically. So if I treat it like this, x squared minus 8x plus 16 is equal to 0. Sorry, not 0, is equal to 1. Now it's just a normal quadratic. Let me go through those steps for solving that. So if I subtract 1 over, we get x squared minus 8x plus 15 equal to 0. X minus 5, x minus 3 equal to 0. Zero product property tells me it's two values, 5 and 3. So that would be my normal quadratic solving process. The thing to remember about these two values, if they plug in to the original inequality here, then they come out to exactly 1. So if I do 5 squared is 25, minus 8 times 5 is 40. So 25 minus 40, it's going to give me negative 15 plus 16 is equal to 1. Similar thing happens with 3. So what we're trying to figure out is which values will give us less than or equal to 1, not just equal to 1. So think about it this way. My x values that are possible, I can represent on a number line. I'm going to put 3 here and 5 here. Now, both 3 and 5 work for this inequality, because if I plug them in, I should get 1 here. So I'm going to put closed circles on here. So what I need to do is I need to double check, well, which other values will work? And so I want to go 3 different areas here. I want to go below the lowest 0, in the middle of the 2 zeros, and above the highest 0. So I'm going to pick 2, 4, and 6. We're going to see what happens when we plug those in. And what I'm checking is, does it come out to a true statement or not? So if I do x equals 2, we're going to have 2 squared minus 8 times 2 plus 16. Is that less than or equal to 1? So we got 4 minus 16. So this is going to be 4 minus 16 plus 16, which these will actually cancel out. So is 4 less than or equal to 1? No. So that's no good there. Let's go to 4. So we got 4 squared minus 8 times 4 plus 16. Is that less than or equal to 1? So it's 16 minus 32 plus 16 less than or equal to, whoops, get ahead of myself, less than or equal to 1. Well, all combined, this will be 0 is less than or equal to 1, which does check out. So this one is good right there in the middle. 6. So I'm going to have 6 squared minus, there you go, 6 squared minus 8 times 6 plus 16. Is that less than or equal to 1? So we have 36 minus 48 plus 16 less than or equal to 1. 36 and 16 together is 52. 52 minus 48 is 4. So is 4 less than or equal to 1? No, it's not. So based on my number line, we know that 3 will work, and we know that 5 will work. And then we also know that 4 works from my work right here. What that means is everything in between 3 and 5 are good values. The only way for this to work out, because it's a nonlinear inequality here, the only way for this to work out that 3, 5, and 4 all work is if everything in between, all those decimal numbers are also going to work. I don't need to test anymore. Once we know zeros work here and here, I should say the zeros I solve for over here, then I'm just finding the range of values in there. So what works for this? My answer here is 3 to 5. Now let's take a look at this graphically, because this one was a little more straightforward with the quadratic. It wasn't too bad for solving, but this is what the quadratic looks like. Here's my 3 and 5. So again, this is, sorry, I should say, this is graphing this version. So what I'm really graphing is this. I'm thinking about when is x squared minus 8x plus 15 less than or equal to 0. And this is what I'm going to represent on my graph right there. So if I look at that, here's those zeros, 3 and 5. All of these values right here, these are all the ones that go below the x-axis. these are all my negative values. These are the ones that are less than or equal to 0 for my output. That's how we can get our answer as well. So looking at this graphically, we're just going to find our zeros like this, 3 and 5, and then look at, oh, well, everything over here is above the x-axis. So it's not less than or equal to 0. And everything over here is also above the x-axis. So again, it's not, it won't be greater than or less than or equal to 0 there. But everything in here, this little spot down here, everything here is less than or equal to 0. So that's what we're looking for graphically. So we can use either algebraic or graphically to help us solve this. When I do the next problem, this is what I'm going to want to do graphically once I get to a certain spot. Because algebra-wise, it's very difficult to solve this without doing a graph anyway. So first thing is, it's a polynomial. I'm going to get it all to one side in reference to 0. So I can subtract 3x squared over. And I'm going to add 24 to both sides. So x cubed minus 3x squared minus 22x plus 24 is greater than 0. So again, I'm going to go to Desmos. I'm going to draw a rough sketch over here just so we can have kind of like a reference here. But the goal is, let's find out where all those zeros exist. So, oops, going back here. Here that one is. Now, very rough sketch, but key is, again, I want these three values here, -4, 1, and 6. Okay, so we know we're crossing at -4, 1, and 6. Okay, so the graph is going to do something like this, and it goes up, down, and up. So, again, the question is, when is that polynomial greater than 0? So if I look at my graph here, it should be all of this section here. All of these values are above 0 here. Everything here is also above 0. So if I look at a number line, so I put -4, 1, and 6 on there, we can kind of think about all those different sections, okay? So everything that's to the left of here is going down. These are all negative values. So it's not greater than that. So we know it's not, and we know it's not this section. And I just remembered, like last time I put my zeros on there as closed circles. I'm not going to do that this time because it's greater than 0. I'm going to get open circles on all of those, -4, 1, and 6. Because if I plug these three numbers into here, okay, we're going to get value something where it's like 5 greater than 5. And that's not true, okay? So that's why we need to make sure that we're putting open circles there. From here, again, this is all above the x-axis. So if that's above the x-axis there, that means I am greater than 0. So this is a good section in between. But now the next section goes back underneath the x-axis, so it's negative. So we don't want that one. But then we're going to be all these values off to the right of 6, all greater than 6, is back above. So here's my final answer for my polynomial. It is the interval -4 to 1 union 6 to infinity. These are the two intervals in which my polynomial is above 0. That's what our goal is here. Okay, if I flip that, I made it less than 0. Now it's going to be these two intervals. So that's what we're looking for when we find this graphically. Okay, here's a couple cases here that are a little bit special. So we're going to look at these graphs and just make sure we understand how to answer these questions here. So again, I'm going to draw rough sketches of each of these. We're looking for the zeros here. We're going to have one more. Okay, so let's look at what happens on this graph. So x squared plus 2x plus 3. You notice this never comes below the x-axis. We have this gap, the lowest point that the vertex is at -1, +2. So when I come back here, oops. -1, +2, -1, +2. So we don't have any zeros. So the question is, when does this polynomial less than 0? Never. It never dips below the x-axis. So since it never does, it does not exist. It's no solution on this one. Okay. However, when I look at when is this above or equal to 0, well, it's above here and here and here and here and here and here. All those points are above the x-axis, which means they are all greater than 0. So the interval in which this polynomial is greater than 0 is all real numbers. It's from negative infinity to infinity. So that's a special case on that one. Okay. Let's look at this one as our last example here. Again, we're going to look at this polynomial when it's greater than 0 or greater than or less than or equal to 0. So here's the graph of that. Now you notice this one comes and hits the x-axis at exactly the 1 point. It does not dip below the axis. So I'm going to draw my rough sketch of that one. Yeah. Draw that a little bit better. Go. It's doing something like this. It's crossing at -6, 0, and that's the only point it crosses. Okay. So when I look at my two possibilities here, the first one says, when is it greater than 0? So if I look at from that 0 point, I want to do it as a number line as well, -6 here. If I look at the point itself right here, that point is not greater than 0. It's exactly 0. So I know that I'm going to leave an open circle on that -6. When I go to the left now, and I go up to any point on here, is that above 0? Yes, it is. All of these points here are greater than 0. So that means that in this direction, all those values will will be greater than 0. And in this direction, same thing. All those are going to be greater than 0 as well. So we get is two intervals from negative infinity to -6 and from -6 to infinity. That's when this polynomial is greater than 0. For my last one, though, it is less than or equal to 0. Well, first thing is, again, if I do a number line, I'm going to put a closed circle on -6 because at that moment, it does equal to 0. So we're good on that exact moment at -6. But if I go to the left, is that ever less than 0? No, it's going up. And if I go to the right, same thing. It's going up. So that means that the solution, there's no solutions that are less than -6 or greater than -6 in this case. So that means my only answer here is -6. So it's weird to call it an interval at 1 point, but that's what's happening here. Okay. So again, today what we focus on was solving polynomial inequalities. We have to find those zeros and then look for important points, either graphically or algebraically. So we want to find important points that are in between as well as above and below our zeros. All right. And that's it for today. Take care, everyone.